Hello and welcome to Living Proof, the Isaac Newton Institute podcast. My name is Dan Aspel. In this episode, we'll be speaking to Alex Kontorovic. Alex is a professor of mathematics at Rutgers University. He also has associations with MoMath in New York and Quanta magazine. We hope you enjoy the episode. Okay, so Alex Kontorovic, thank you so much for joining us here on Living Proof.
My pleasure. Thanks for having me.
With me today also is Christy Marr, who's the Deputy Director at the Isaac Newton Institute.
Hi, Alex.
Hi, Christy.
We are going to be talking all about you, Alex, because I think there's a lot to cover and a lot of interesting strands to what you do. The main topics I wanted to talk about were your work at Rutgers and your communication of maths, but also you're involved with two really interesting organisations in Quanta magazine and in MoMath, the Museum of Mathematics in New York. So, would you like to begin by giving us an introduction to yourself and what you do professionally?
Sure. Yeah. So I'm a professor of mathematics at Rutgers, as you said. That's it's a research institution. So I teach a course or two a semester typically, and do research the rest of the time, advise graduate students and postdocs and the kind, and travel to conferences, just the usual things that any academic does. And then this for 2020, 2021, I've been the visiting professor at MoMath, as you said, the National Museum of Mathematics in New York City. So that involves, it's not that dissimilar from being a research mathematician. The difference is, instead of teaching sort of undergraduates and PhD students, I give some lectures from time to time to the general public and try to get them excited about all things math.
That sounds like the great challenge of being any kind of teacher. Getting people excited about the subject.
Absolutely. Yeah. It's sort of, that's why I said it's not so different. It's the same as getting an 18-year-old excited about calculus as getting a 7-year-old excited about whatever it is we're talking about. I mean, one of the things I try to do with the museum is, and in general, I try to express some, how shall I put this? Very few people think that mathematics is still being researched today. They think it was all invented, if not 2,000 years ago, certainly 200 years ago, since that's all they ever see in school. And it's really a shame, because I'm jealous of these physicists who get to write books that tell the public what they just came up with in the last 10 years. And mathematicians, I don't know, maybe we're more shy or something, or we keep to ourselves, or it's that much harder. Maybe if I should knock some physicists, that math is that much harder to as a subject. Never mind to communicate it to outsiders. I don't know. I don't know that they would agree with that. I'm sure physics is very hard too. But we as a profession have not, at least in recent times, done a very good job of communicating that we exist. Would already be a good start, that there is such a thing as research mathematics. And some of it is even, maybe not the proofs, but the statements are sometimes somewhat accessible, at least in some very watered down way. And we should be doing a better job, I think, of communicating that to the general public.
Yeah, absolutely. And I think, Christy, as a fellow academic, I think you had some interesting questions for Alex about mingling his communication work with normal academic work. So if you'd like to fire off with that'd be fantastic.
Yes, I mean, I just love all that you're doing, and I adore communicating mathematics with children as well. I think it's really exciting seeing eyes light up. But have you, at any stage in your career, felt a tension between your research mathematics and your communication of mathematics? And have you ever felt that one community was slightly suspicious of your work on the other side of the tracks?
Yeah, that's a great question. It's funny, when I first started doing any amount of communication, it was actually the result of sort of the National Science Foundation, the NSF here in the US, forcing me to. Well, not with a gun to my head, but there's a grant that's sort of an early career grant called the Career Award from the NSF, and it requires a larger amount of public engagement, let's say, than a standard. There's sort of they really want some broader impacts that are more significant than that of a standard grant. And I was teaching at Yale at the time, and the what I proposed was that I would just sort of join up with some friends who were already doing some outreach, and I would give like a lecture or two a year to the public, and that would be my broader communication. And I got the grant anyway, but there was a mark saying, your broader impacts are not really that are the weakest part of this proposal, and we want you to do better. But we'll give it to you anyway, and so do this. And so I did that for a few years, and then I moved to Rutgers, and so of course I had to do something to justify this career grant, and I didn't know what to do. And the Museum of Mathematics had just opened in New York City, which is not so far from Rutgers. They opened, I think, 2 years before I moved to Rutgers. And so I came to them and said, hey, I need to do some public outreach thing. Can I give a talk here? And they said, who the hell are you? And so I had some other public things that I was supposed to give. And so they came and saw that, and they said, okay, I can speak there. And so that was sort of the beginning of my interaction with them, was not because I wanted to do this, but because being a research mathematician and wanting a prestigious grant, I was sort of forced into it. And then I realized I kind of like it. I mean, I always liked talking to, I just like kids, kids are kind of amazing. And now I have some of my own, and I talk to them all the time about all kinds of things. I don't think I don't know if they would agree that I don't push math on them, but so it was sort of natural to transition from talking to them to talking to other kids, and kids includes kids of all ages. At the museum, we have people from ages 5 to 105, and they're all kids at heart who want to just be excited about learning something new. So to answer your question, I think there is, at least in an older generation, something of a feeling that if you're doing outreach, then you're not a real researcher. And I think that feeling is going away. And I think there are a lot of people who are getting involved in more outreach. And certainly all of the top level people who I've talked to since doing this job have all said to me, it's fantastic that you're doing this. Thank you for, that doesn't mean I'm going to get involved, but at least you're out there doing it. So thanks for that. So I think there's now really, researchers appreciate that someone's doing this. That doesn't mean they're going to do it themselves, but I think there's not a stigma to it, certainly, as I would have thought there could have been before.
And so do you think this is now part of who you are forever? Do you think that no matter whether you have a fellowship that obliges you to do this or not, do you think that this is just who you're going to be as a mathematician now, just walking along these two parallel paths, intermingling paths?
Yeah, that's a good question. My term at the museum expires in a month and a half, or a month now. I'm looking; it's already the end of July, and then I go back to sort of being a research mathematician. And when I'm called upon to give, I'm even as a research mathematician, I am called upon from time to time to give sort of lectures for the broader public, but they're not on a regular basis. Maybe 5 of these a year or something like that. And so the question being, do I want to continue communicating? Well, I think I do want to continue in some capacity, to the extent that if there's something I want to say, then it's so easy these days to just throw together a Zoom call and say, hey, anybody wants to listen to this, I'm just going to talk about it. And the museum has been very supportive. So if there's something that I want to do with they have this much bigger reach, obviously. So if I propose an evening activity for them, they're usually happy to add it to their calendar. But I also, I haven't stopped writing papers and fighting theorems and advising students and postdocs and so on. And I have no interest in stopping that. That's also a big part of what I love doing. I'd probably say even now I spend 80% of my time on something like that, and then 20% on the public engagement.
That's fantastic. I have a sort of privileged position, a viewpoint, let's put it that way, because I'm relatively new to working in science communication. I've worked at INI for 4 years, and all of the people who I've met, including yourself, Alex, are very, very passionate, very interesting people who are mathematicians. And I guess there's a really unfair, and this is the question for you, is it unfair? And where did it come from? There's this really unfair stigma attached to mathematicians, which you touched on earlier compared to physics, that mathematics perhaps is viewed as being somehow less interesting, and that the people that undertake it are somehow less keen to communicate it. And that seems to be melting away really quickly. And I'm wondering if you, Alex, and Christy as well, have any thoughts on why this is happening recently, and just how much the public has missed out on, in the past because of not having this level of communication from maths.
It's interesting. I mean, there have been people historically, like, Martin Gardner is a famous example of someone who had a big impact on bringing the latest thing that John Conway thought of that's this brilliant game or whatever, a toy or something, to the general public. But you're absolutely right. I mean, look how many Nobel laureate physicists have written popular accounts of their theories, and now look at how many Fields medalists have done the same. And it's just no question that as a group, we mathematicians, again, I don't know that it could be that the things we're doing are so far removed from people's everyday experiences that for someone to take their very precious time away from research to try to communicate it, and at what cost and at what benefit. I could very well see a cost benefit analysis to look, I'm a researcher, I'm just going to plow ahead with my theorems. I'll tell my PhD students what I'm doing, obviously, and I'll tell the other mathematicians that want to know. But I'm not going to spend time on this for the general public. It's just not worth it. Not worth my time. Sort of a lesser researcher should do the exposition than myself. I think people now really value the fact that they see that there's a demand too. It wasn't clear, I think, before that there really was a demand. But guys like 3 Blue 1 Brown, Grant Sanderson, has millions of people watching, a 30-minute video on highly advanced mathematics. Like, people want this. People want this. They're ready for it. And YouTube and social media and other outlets are venues where people can really access the public and get that feedback. So I think there is a demand, and the more people see that there's a demand, the more people are willing to give.
That's an exciting thought. Can I ask, how do your students feel about it? Are they excited to be part of groups with the sort of celebrity member of the of the team, or how is their reaction?
I don't think any of them think of me as a celebrity, and I don't think of myself as a celebrity, obviously. No, in fact, I try to keep them away from that because certainly the ones that want to have a career in research, I advise them not to spend any significant amount of time on anything other than getting as many papers out as quickly as they can with as much depth and so on as possible, because early in your career, it's absolutely essential if you want to be at a research institution. What I'm doing is sort of cherries on top. The research, it will always come first at top research places. So they don't have the 20% that I'm taking off of my research to do outreach.
Yeah, absolutely. And of course, all of this leads into the two organizations which we've already mentioned. So Quanta magazine and MoMath. Should we talk about the former first of all? Because as a non-mathematician, I'm the only one on this call who's not a mathematician. I really am very excited when I get the weekly newsletters, the email bulletins from Quanta, because it tells me about the really profound, potentially profound implications of the research which is ongoing at the moment. And for someone that can't get on board with pure maths because it's many years of study away from me, I find that really inspiring. So I think I'm a sort of fairly good example of that kind of audience. So what drew you to working with them, and what's the nature of your work with them?
Yeah, so I really can't take any credit for the amazing things that they're doing. I'm simply on the scientific advisory board. So what that means is if some, I go to conferences, I'm around mathematicians all the time, and there's a lot of gossip going around. And so if there's some bit of gossip about some amazing new result coming out, then if Quanta hasn't heard of it already, which these days they have their spidey tentacles out looking for results just like I am. But when I do hear of something that they have that's really that they might consider, I pass it along to them. That's basically the extent of it. I'll suggest some people for them to talk to, some topics for them to cover. Sometimes they take my suggestions, sometimes they don't. Sometimes they do things, lots and lots of times they do things completely unrelated to me. So that's just sort of, again, another cherry on top, which takes, in principle, very little of my time. Although more recently, we've been doing some actual videos that, we did one on the Riemann hypothesis about 6 months ago. So that took a little bit of time, but that's really just a one-off or a two-off thing that I do with them. Most of what they do without me, so I can't take any credit for the amazing things that the people working there are doing. That's very hard, and they work very hard at it. So,
and when you were a student, I'm afraid I actually don't know how long Quanta Magazine has been running, but I'm guessing it wasn't when you were a student.
No, it didn't. None of this existed. YouTube didn't exist. Quanta didn't exist. I mean, I'm so jealous of the people who are growing up now and have access to all of this amazing stuff anywhere around the world for free at the click of a button. And in my day, you had to, know somebody who knew somebody who would sort of slip you a research project under the door or something. Now you can go and read about what top people are doing, and really, try to understand and interact with it.
Or a VHS cassette, maybe.
Exactly.
That's really interesting to hear. I mean, I too feel that kind of excitement about there being such a wealth of things. I do wonder how it will be noticed in 10 or 20 years' time, whether there will be simply more people applying, not that there's any shortage now, to significant maths courses. It would be interesting to see just how the perception of maths changes as well, I think. And all of this kind of work must feed into that.
Yeah. The developing the skills at very high levels of doing mathematics, that's just a very difficult thing for anybody anywhere. And if you're not motivated, then why would you do it? So hopefully all of the amazing outreach things that all kinds of people are doing will help with that. And I'm not yet it's been a while since I taught sort of first year undergraduates, but the next time I do, I'd be curious to see how many of them came from, Veritasium's channel or 3 Blue 1 Brown or Numberphile, these sort of popularizing channels. How many of them actually watch those channels and get inspired by them, and that's why they're taking my course? That would be really, really fascinating, because to me, those guys are making a huge impact in, to get the skills, they still have to come to somebody like me and be trained for however many hours during the course of a semester on whatever topic it is. But to get inspired is just amazing what these channels and Quanta and the other people you mentioned are doing. So we'll see the impact of that. I think you're absolutely right. If not already, then in a few years.
And Christy, I don't know if you wanted to say anything on that same point, because you have a history of being a teacher of secondary school, I think, mainly. Is that right?
Yes. So before I went back into academia, I was a secondary school maths teacher, and I just loved that. And in fact, back to what you said earlier, I loved bringing university mathematics into the schoolroom. And if you just couch it in a gentle way, actually, it's really, really understandable by students. And I had a number of my pupils coming back to me saying, when they were going off to university, and they're saying, I was the only one in the room who recognized this notation just because you'd introduced it to us at a school level. I was the only one who wasn't intimidated by it. And I just kind of thought, well, actually, you're bright, you're like sponges at that age, you're just absorbing stuff. So let's just throw it to you. And there's no reason why you can't introduce calculus, to kids, with an appetite for it at age 11 and age 12, and just gently build that up. And, there's a lot of quite sophisticated math that you can just introduce through Venn diagrams, for instance, or geometry in general. Just visual tools actually can introduce really quite subtle mathematical concepts. So yes, corrupt children into the joy of mathematics at an early age is my mantra.
I can't agree with you more. I mean, it's absolutely, so we almost go in the opposite direction. We don't call them equations, we call them number sentences, because the word equation scares children. We don't show them algebra until they're in 7th grade. So from K through 6, all they see is numbers, they see fractions, they see decimals. All of a sudden in 7th grade, after they think they got the hang of this math thing, now there's X. What the heck is X? X should be in kindergarten. Kindergartners should have, 2 plus 3 equals X. What is X, right? Just let that be, because they don't, you see, kids, this is what I always tell my PhD students. Kids, including PhD students, they're too dumb to know what's hard. Like we old people, we know that, oh, this is hard. Like you'll never figure this out, but they're too dumb to know what's hard. So they just do it.
Yeah.
And they're too dumb to know that something's impossible. I tell them this is impossible. And then they go, oh, okay, but maybe it's possible. And then they go do it. And then they show me and I say, okay, I was wrong. You were right. It is possible. So yeah, we under challenge. This is one of my pet peeves, is just how much we under challenge people and how much we leave on the table, how much, there's so much potential that is not being realized because we coddle kids and we protect them from these complicated mathematical ideas, which is the exact opposite of what we should be doing. We shouldn't be pushing them. There's a very fine line between getting, saying things at them that they're not ready for and saying things that they already know and sort of making math boring. And it's very hard to do. I mean, it's very easy for me as a researcher and popularizer to stand there and say, oh, we should be doing this, this, and this with education. But I'm not the one I'm not the teacher on the ground with the kids in the classroom day in and day out. Like those people have some of the hardest jobs, I think, in the world. That said, I think there's a lot of potential for what we could be doing with kids at a young age and introducing them to advanced mathematical concepts. I mean, one of the first things I do with any kid, once they can multiply by 3, is I teach them the 3x plus 1 problem. You have a number. If it's even, you divide it by 2. If it's odd, you multiply by 3 and add 1. And you just do this over and over again. And they'll immediately recognize that any number they start with, they're going to get back to 1. And then I say, why? And I say, I don't know. And I say, you know what? Nobody knows. Nobody even knows if it's true. And that's an open problem in mathematics that you can tell a 6-year-old, So that's the kind of thing that I've been thinking a lot about. How can we introduce this to more kids to get them just aware of the existence of mathematics that's unknown? It's not all look it up at the end of the book. The teacher's manual has the answer or something.
I love that example that you have given, because what I really like is examples of maths that you can discuss around the dining room table. The whole family can do it. And the 6-year-old can have as good an intuition about it as the adult can, and they can all exchange ideas. And that's one of the things that I think is most beautiful about mathematics, when you can think of one of those problems where everybody has a grasp of it, and it's very easy to say, but there's something really subtle behind it.
Absolutely.
That sounds tremendous. I'm trying to think of examples with my own children of how you try to pass on something that you're really excited about and you think they should be excited about too. And as you say, it's a really, really fine line between giving them just enough so that they're interested and they pursue it, and absolutely drowning their interest completely, so they will never take it up for as long as they live. How do you find, I'm not sure how old your children are, Alex, but you mentioned that you think you're doing a good job of introducing it to them and they may disagree. How's that going?
Well, I was going to say that I don't think I push it on them and they may disagree.
Sure. Okay.
Yeah. Whether I'm doing a good job or not is anybody's guess. I mean, I have an N of 2 experiment that I'm running, and they're turning out very differently. So they're like sort of 2 N of 1s experiments, not even an N of 2. Yeah, I'm not doing anything systematic. I'm just if there's an opportunity, dinner's done, and you want dessert, you want some M&Ms. How many M&Ms do you want? I want 7, and I give him 5, and he goes, hey, that's not 7, and I go, okay, how many more do you need? Like that's just that alone is the beginning of where you start, getting them to think and having thinking be a normal part of conversation and every, things being quantitative, things being this matters. Like M&Ms matter. 7 minus 5, they will never understand 7 minus 5. You have given me not enough M&Ms. I need more M&Ms because I said 7 M&Ms and you haven't given me enough. This is real. This is the real world now.
Yeah. That's tremendous. Yeah, I find probabilities with dice games are something that we can all enjoy, as long as it doesn't turn into gambling. So
Yeah.
that's fine. That's great.
Monopoly, board games. There are all kinds of. Yeah, I think my older one learned to understand sort of fractions and multiplying through Monopoly. You want to buy this many, or dividing. You want to buy 4 houses for this property, and the houses are $50 each. You only have $500. Do you have enough? Do you not? How much will you have left over? What if you land on, Boardwalk or something, and etc.
That's definitely the most positive use I've ever heard of Monopoly. That sounds good.
In our family, it's Perudo. In fact, we were playing Perudo last night. Do you know Perudo, Alex?
I don't. I want to check it out.
Oh, it's a good. How old are your kids?
The older one's 9 and the younger one's 5.
Okay, so it'll be intuitive for the 5-year-old, and they'll just copy and pattern match for the old one, and the older one will get it. And so you have a certain number of dice. Everybody has a certain number of dice, and then you predict how many 5s there are collectively between you, and 1's are wild. And so you just kind of, and you can't see anyone else's dice other than your own. And then if you lose, then you lose a dice, and then you have less information. So then there's nice discussions around that. So it's a really nice game for introducing an intuitive understanding of probabilities to kids.
That's amazing. I have to check that out.
Yeah, and there is no child alive that doesn't like rolling dice. So that sounds perfect.
Absolutely.
And plenty of grown-ups too. I count myself in there. So to move on to MoMath, which I'm really interested to hear about, to give you a bit of context, we were fortunate before the pandemic to have a visiting academic to the Institute who was part of Mathematicum in Germany, which is also a sort of museum, for want of a better word, celebrating mathematics. And if you know it, great. If not, I'd highly recommend going and looking at the website, because it does look a lot of fun. I've still not been, and probably because of the pandemic, thinking about it. But tell me about MoMath. Tell us what the public can experience when they go there.
Yeah, so now that MoMath is open once again, just opened beginning of this month after being shut for a year and change for the pandemic. The whole idea at MoMath is for kids to have a physical experience with mathematics. Not only is it a game, it's a whole body thing. So one of the first things that people do when they come in is they see the square wheeled tricycle. So there's right in the middle, bright yellow colors. You sit down on this tricycle and you obviously notice that its wheels are square, and yet when you ride it, it feels like a smooth ride. And how could that possibly be? And of course, there's the joke, right, of that works as well as a square wheeled bike or trike or whatever. And that's because everyone imagines the road being flat and the bike having this clunky, flopping down every time it turns. And of course, the mathematical solution is you make the road curve so that the wheels just perfectly align and the seat stays straight as the bike moves across. And the question is, what's the shape that you need to do that? That's not a calculation we can ask of even our high schoolers, and probably even my college kids would take a minute to figure it out. But the fact that there is such a question, and that it can be answered, and it can be answered quantitatively, and it can, it's sort of surprising uses of mathematics is all about re-asking the question. What's the right question? So it's not obviously a square-wheeled bike won't ride smoothly. It's a question of but on which road would it ride smooth? So that kind of thing, where they're using their whole body. There are all kinds of games throughout the museum. There are all kinds of other activities where they can. I can't describe there's 50 exhibits all on different kinds of things. There's one where you sit in a chair and you have straight ropes all around you, and as you spin, the ropes remain taut and straight, and yet you see a hyperboloid forming. because it's a doubly ruled surface. So every exhibit is meant to be played with immediately. You're not standing there reading a long list of instructions, and you just start playing whatever it is. And hopefully after a certain amount of time of playing it, you start asking, wait a second, how is it that this even works? Why does this exist? Like, what's going on here? And that's where we're hoping people take home some excitement and some that they want to read further and learn more about what they just experienced. So that's a big part of what the museum had been prior to the pandemic. Now, over the last year, as a result of the pandemic, we've developed a whole other side, which is now all of the programming is virtual. Well, now we're starting to do hybrid programming. That's a whole other thing. I don't know if they'll decide to continue that or if they'll go back to having everything be in person. But it's been, so the virtual component has been extremely, I think, successful, because we have people from 100 countries around the world, all time zones. We have programs that I run in the afternoons that I'll have people logging in and I say, oh, where are you from? I'm from India. Like, you're from India, or you're Indian? No, I'm in India now, and it's 2 a.m. and I got up to participate in this. So it's really amazing. And it's making a global community of people who want to who can't get to New York City for all kinds of reasons, and they don't have to. It doesn't cost a plane ticket from India to go see what's happening at the museum. You just hop on a Zoom call. So that aspect of it has been really amazing, and I expect it'll continue.
That's super exciting. I love hearing stuff like that, because it's, I mean, correct me if I'm wrong, it's like the only positive to have come out of the past 18 months.
Exactly.
Is this huge growth in the ability of people to form a global community, as you say. And I will be going on the website and looking and seeing what I can see this evening when we're off the call. I really, really love what you said about making it physical, because that's something which we heard about Mathematicum previously, and it seems to be really key to getting people involved who don't necessarily think about themselves. Well, they form their own mental block. I think like, I'm not good at maths. I can't do maths, but actually just presenting them with something to play with, everyone will do that. And there must be a lot to be said about the link between physical movement and learning, which is something that you can lose a lot in a static classroom.
Yeah, absolutely. Again, I'm not a researcher in sort of modes of learning or anything like this. I have my small number of examples of people that I interact with, and every chance I can get them to stand up and do something and really move around, that really helps. I mean, the other side of it is that can help them get excited about something. But there really is, at the end of the day, no substitute for sitting at home by yourself with no TV or iPhone on, and a piece of paper and a pencil, and calculating until something. I tell my students at the beginning of the year, my neurons in my brain are beating at some strange pattern, and my goal is to jump around like a monkey or do whatever I have to do so that your neurons in your brain are beating at that pattern. And there's nothing, I can't force them into it. There's nothing I can say, there's nothing I can do until you make yourself do whatever it is. I guess I try to tell them, no one can teach you math. You can teach you math. I can't teach you math. I can say words, I can write things down. Maybe you'll understand them, maybe you won't. Actually, if you think you understand them, that could be even worse. Because if I give a very clear lecture and you sort of understand everything, then you go home and you feel like, yeah, I got it all. I don't need to go over my notes, or I don't need to watch a YouTube video or something. And then a week later, they realize, no, they don't have it. They maybe had it for a second or something, but it went in 1 year, out the other. So there's definitely, we need both. We need the full body, the fun, the interaction, and we need time spent just, by oneself, studying, thinking about these things deeply, so that they really are inside your head and not just something that you did once with your hands and feet and thought you understood it.
Yeah, absolutely. Everything that's not used doesn't stay.
I love what you're saying there, and I think there's something that from my teaching days that I always thought that the expression giving someone something on a plate, and I kind of think that being a maths teacher is like that you present things and you put them down in a tantalizing way in front of your students, and it's by them picking them up and playing with them that actually they suddenly realize the worth of something. My other technique is stitching them up by making them do a very, very long circuitous route to get to a particular answer. And then you suddenly go, and let's look, you could have just done this in 2 lines this way. And that's a really effective way of getting somebody to go, those are the 2 lines that I need, and remembering them. So, but I like the idea of giving them almost literally something on a plate, and they can just pick them up and play with them.
Yeah, absolutely. The 2 lines, I mean, that's what is it? Build a better mousetrap or something, right? There's like you've learned how to do something, and then hey, here's an idea. So what mathematicians really value is ideas, new ideas that can help you. There's an idea that made that long circuitous route into something where they can just beeline for it. So it's those ideas that we really value. That's what we want to get across to students, and let them have their own ideas, and let them enjoy coming up with ideas, because that's really the essence of mathematics.
That's wonderful. Your involvement, you said, is coming to an end at the end of August, at least your current involvement.
Yes, exactly. So the distinguished visiting professorship position is an academic year position. So in September, Steve Strogatz will be the next visiting professor there. So that's very exciting. He's one of my heroes in public communication and mathematics. So and he'll be around New York City, so he'll be nearby. So I'm very excited about that.
Fantastic. There's one other thing I wanted to ask you, Alex, and I'm kind of privileged because normally it's me conducting these interviews, and I feel like I have a hang on asking people questions, about themselves. But as I said earlier, I'm not a mathematician, but Christy is. So would you like to talk about your research interests?
Sure. Yeah, I can just say, very broadly that over the last 100 years, so my research is in number theory, which people who haven't heard of number theory, it's, we sort of ask basic questions about whole numbers, and we try to answer them. But over the last, maybe 200 years, it's turned out that in order to answer basic questions about whole numbers, you need things like geometry of non-Euclidean spaces, you need harmonic analysis, you need representation theory and group theory, and all these other tools. So it's sort of what modern number theorists do is, again, they're still trying to answer basic questions about whole numbers, but the techniques sort of, you get farther and farther away from the original question, and more involved in the techniques and studying dynamics and geometry and harmonic analysis. So that's what I spend a lot of my time on, even though at the end of the day, the answer should be some easy to state theorem like the 3x+1 game we were playing before.
So for me, I'll give you the thing about it. So number theory really got me back into mathematics. So as I say, I was a secondary school maths teacher, and I found myself reading elementary number theory textbooks as like bedside reading. And I suddenly thought, actually, do you know, maybe I really need to go back and rekindle my love of mathematics. So in fact, it was number theory that got me back to doing my master's and doctorate and things like that. And it was really the beauty and the simplicity and the elegance, and so you can state something in one line that's really simple to understand but quite subtle to prove. And was it that mathematical beauty and elegance that drew you to that field, do you think?
Yes, absolutely. So I had a really great, I had a lot of very great teachers, but one of them was a mathematician named Eli Stein, who passed away a few years ago, unfortunately. But he was a great analyst. And when I was an undergraduate, he was developing a series of textbooks about analysis. So analysis means calculus, but done rigorously and sort of with every T crossed and I dotted. And he was developing this series of books about real analysis, complex analysis, which is calculus with using complex numbers as inputs and outputs, and harmonic analysis, like Fourier analysis, and so on. And he was developing this series of books, and he was trying to showcase to us the power of analysis by finishing for example, his complex analysis book includes the proof of the prime number theorem, which is an old statement in number theory that people were very interested in. It was eventually solved using complex analysis. And then his book on Fourier series ends with a proof of something called Dirichlet's theorem about primes and arithmetic progressions. So he would end his analysis books by showing the power of analysis, that it can settle problems in number theory. And he's saying, isn't this great? You should all go and be analysts. And I sort of received the opposite message. Isn't it amazing that number theory is this beautiful subject where you can grab tools from anywhere, and you need tools from almost everywhere to settle basic questions about whole numbers. So, he had a huge influence in me, perhaps not in the way that he thought he would, in driving me to number theory. Granted, analytic number theory. So I use a lot of the techniques that I learned from him, but not to do analysis, but to do number theory.
That's very nice. I think that as mathematicians, we're really kind of magpies or thieves. We kind of go, oh, that's a nice little technique. I can just steal from there. And of course, that's actually in a way what the Newton Institute is all about, is bringing together communities that are working on one branch of mathematics and on another branch of mathematics, where we think each can enlighten the other. And that's where the true magic of I&I happens, is over these long conversations where suddenly there's a connection between these two communities.
Absolutely. And I've had some great visits to the Newton Institute where exactly that kind of thing happened, with people from different communities coming together and talking about something, and somebody having a spidey sense. Wait, I think something that you just said might be relevant to what I'm trying to do. And you might have already had some ideas in that field that could make progress in what I'm trying to accomplish.
It's interesting, actually. Quite often these connections happen, and it's people on different programs who we didn't intentionally necessarily, well, semi-intentionally, because we always think about what programs we run in parallel, but it wasn't strictly intentional. It was somewhat serendipitous that people ended up sharing an apartment together, and so they're, into the small hours, they're sitting and talking about things, and then suddenly find they're writing papers together.
Yeah, absolutely. One of the most important things mathematicians in this country do is they imported the British tea system. So we have tea every single day. It's kind of amazing, because the other departments look at us like we're crazy or something. What do you mean? At 3:00, everybody just stops what they're doing, and you go to the lounge and you get a cup of coffee and a cookie, and that's okay. And not only is that okay, there it is, absolutely. Not only is that okay, that's an absolutely necessary component to any, why be in a department? What I've really missed, by the way, for the last year of not being in a department, we tried to have a department tea, but it's just so hard to keep it up over Zoom. But it's so vitally important to every single day just show up and be in the room, and you say hi to people and so on. But then one time out of 100, someone will be in that room, and you'll say, you know what, can I bother you for a second? Let's go. And there's blackboards everywhere, of course. It's a math department. And we go over to the blackboard, and they say, I was thinking about this and I'm sort of stuck on it. I don't know if you know anything about it. And, one time out of 10, they'll say, actually, there is something that you could do here that will, come over to my office. And then, conversation continues. So I agree with you 1,000%. It's the serendipitous interactions that happen at things like conferences, like workshops, at tea, that where the real magic happens. So mathematics is almost, there's something called a Cantor function in mathematics. It's a function that sort of never, ever rises. Its derivative is always 0, and yet it manages to get from 0 to 1 in time 1. And so that's sort of what research is. It's the derivative is always 0. I'm always stuck. I'm never, ever making progress. And yet somehow I look back 6 months later and a paper got written. So, it's these little serendipitous instances that where the actual progress is made.
So my records tell me that you were at I&I in 2004, 2014. So I'm hoping that we can extrapolate from that, and you're going to be visiting us again in 2024. Your
memory's better than mine. Yeah, I think that sounds about right. Yeah, I'm always very happy to be there. It's such a great place to be and to do mathematics.
Yeah, you're making me very excited about the, I guess, medium-term future. Because we're moving back towards we already have participants in the building, and the past 2 programs have been hybrid in some way, so a lot of virtual participation, but we are gradually moving back to some kind of normality, and
We have a workshop running today. We have participants in the seminar room one right now. It's just a joy to behold.
Yeah,
that's amazing.
I hope the same is true for your department too, Alex.
As far as I know, we are going to be up and running, in September, hopefully.
Oh, it's really exciting. I tell you, it's a strange thing to say on a podcast because it sounds quite meta, but I listen to a handful of podcasts based in the US, and completely incidentally to the topic of their conversations, it's really interesting to hear what they say about the pandemic, because some say things like, well, when we had the pandemic, of course, as though it's over. And I guess that might feel the case in some parts of the US. It's a huge country. But it's been a rocky road, certainly in the UK, and a relatively uncertain one even now. But the progress is quite apparent. I think it's like you're talking about your research. I think when we look back to a year ago, the situation is undoubtedly better now in many ways. So,
absolutely,
trying to hold on to something hopeful.
Ditto.
Yeah, Alex, I think we've taken up a perfect amount of your day, and it's nearly lunchtime for you. It's tea time for us, in fact. I think, Christy. So we'll have to put the kettle on. What does the rest of the day hold for you, Alex?
Meetings with collaborators on Zoom. That's what I did before my call with you, and that's what I'll be doing after the call. So it's just, in that sense, it's been also helpful for research, because there are now research projects, papers that I'm writing with people who I've never been in the same room with, never been in the same country with, as far as I know. People that I met at a virtual conference, and we struck up a conversation. We realized we had a common interest, and now we're writing a paper together. So this morning I was on with a collaborator in Hong Kong, and after I talk to you guys, I have a collaborator in Boston who I'm going to spend the afternoon with. So that's my day. Is I don't leave my office, my basement in my house, and I'm just on Zoom the whole time, for better or worse.
Well, you're absolutely making the best of it by the sound of it. So Christy, I think we'll say goodbye to Alex now, unless there's any parting question you wanted to fire.
Oh, just many, many thanks, and we look forward to welcoming you back to I&I. So thank you for your time. It's been lovely chatting.
It was such a pleasure.
Yeah, thank you for joining us, and Alex Kontorovic, thank you as well. It's been a real treat.
Thanks to both of you, and again, I hope to see you at the Newton Institute sometime soon.
Yeah, there'll be a cup of tea waiting.
Wonderful.